Okay, so here we are with the next stoichiometry video. So now this is the limiting reactant video. So we're given a lot more information here than we did in our regular stoichiometry video, right? We have a different chemical reaction here that we're going to watch, right? And so it says now, suppose you react together 17.4 grams of N2H4, so that's one of our reactants, and 22.7 grams of N2O4, the second reactant. All right? Your reaction produces 16.4 grams of nitrogen, so we're looking at that product there. What is the theoretical yield of nitrogen, the limiting reactant, and the percent yield? All right, so we're given a lot of information, so let's write it all down. All right, so we're given 17.4 grams of the N2H4, all right, so this one, and 22.7 grams of N2O4, all right, so this one, all right. And we were also given 16.4 grams of nitrogen, so we're given that one right there. Okay. Now, since it says produces 16.4 grams of nitrogen, this is our actual yield, right? Produces or obtained, right? That's telling us that the reaction already happened. And so we know what we've already made. And what do we want? Right, we want theoretical yield. All right, theoretical yield of nitrogen. We want our limiting reactant, and we want our percent yield. All right, so we want to get three different things in this example. Okay. All right, so we're gonna, in order for us to solve this problem, right, we need to compare how much product, how much nitrogen we can get from each of these separately. Right? So we're gonna do them separately. Starting with the 17.4 grams of N2H4, we want to change that first into nitrogen. Right? Nitrogen is the product that we're worried about here. Right? So starting with the N2H4, right? Change the N2H4 into nitrogen. All right, so we're not going to worry about N2O4 just yet, and we're not going to worry about water at all. Right. Okay, so start with the first one. 17.4 grams of N2H4. All right. Just like we did in the regular stoichiometry problem, we're going to convert from grams of given to moles of given using the molar mass of the N2H4. Right. So for every 1 mole of N2H4, we have 32.05 grams of N2H4. Grams of N2H4 cancel. Okay. And now we are a moles-to-mole ratio of nitrogen to N2H4, so 3 moles of nitrogen for every 2 moles of N2H4. Okay. So moles of N2H4 cancel. Remember, we're looking at coefficients here. 3 moles of nitrogen, 2 moles of N2H4. Right? Remember, they're all related by their coefficients. And then finally, change our moles of nitrogen into grams of nitrogen using the molar mass of nitrogen, which is 28.014 grams. All right, per mole. So moles cancel. All right. And so we end up with 22.8 grams of nitrogen. Okay. Now, we need to see how much nitrogen we can make from the N2O4. So let's do the same thing again, starting with the 22.7 grams of N2O4. Okay. So we need the molar mass of N2O4, and that's 92.01 grams of N2O4. Grams of N2O4 cancel. We need the mole-to-mole ratio, because now we're looking at N2O4 here. All right, so N2O4 and nitrogen. All right, so nitrogen again is 3 moles, but N2O4 is just 1 mole. Okay. So moles of N2O4 cancel. And then the same thing here, we need to bring the same thing, the same molar mass that we used here, because we're still going to nitrogen. So 28.014 grams of nitrogen per mole of nitrogen. Moles of nitrogen cancel. Okay. And this gives us 20.7 grams of nitrogen. Okay, so now that we've done this part, we can go ahead and answer our first 2 questions. The theoretical yield of nitrogen and the limiting reactant. So this is, remember, this is called the smaller amount method. that means that we're going to compare these two setups and see which one gives us the smaller amount. Right? So we have 22.8 grams of nitrogen here and 20.7 grams of nitrogen there. That means the smaller amount is our answer for the theoretical yield. All right? So 20.7 grams of nitrogen is the theoretical yield. And then the limiting reactant is whichever reactant made it. So the limiting reactant is N2O4. Okay? Okay, good. So now that we've answered, all right, our first two questions, last thing we have to do is our percent yield. All right? So I'm trying to move this up a little bit. All right. Okay, so, all right, so last thing's percent yield. So percent yield, if you remember, is equal to actual yield over theoretical yield times 100. So our actual yield was given as 16.4 grams. Our theoretical yield is 20.7 grams times 100. And so that comes out to be 79.2%. Okay. All right. And so that would be your typical limiting reactant, theoretical yield, percent yield type problem. Okay, so hope that was helpful. And then I'm going to go ahead and now make the thermochemical stoichiometry video. Okay.